Heritage Conservation for Adaptive Reuse. I am Andres Winson C. Ureta of De La Salle University for the Cherish Seminar Workshop on Seismic Hazard Assessment and Rapid Visual Survey of Existing Heritage Buildings. First, let me give you a background on the research collaboration between DLSU, CPU, and UP Visayas. A group of undergraduate students from De La Salle University and Central Philippine University collaborated to do research for their undergraduate thesis. And one of the topics considered is these cultural heritage structures at Calle Real. A paper was presented in 2013 in the International Conference on Cultural Heritage and Disaster Risk Reduction. It was presented by Kirk Yu, the BSMS student from the LSU, on supporting local initiatives in preserving heritage buildings in Iloilo City through risk assessment. Co-authors include yours truly, Dr. Ibabaw, and Mr. Noel Hechonova of Iloilo City Environment and Natural Resources. First, let me present some impact of natural hazards to heritage structures, specifically during the Bohol earthquake of 2013. The Bohol earthquake is one of the strongest quake in the Visayas in 23 years. It is described as an earthquake with energy equivalent to 32 Hiroshima bombs. It was a magnitude of 7.2, and from this earthquake there were many old churches which were damaged and destroyed. Shown on this slide are the heritage structures, specifically churches before the earthquake and after the earthquake. We have Baclayan Church before and after, Lubbock Church before and after, and Taoist Church before and after. Aside from churches, there were towers which were damaged, like this Maribohok tower, which was damaged due to the earthquake. These are additional photos of damaged churches. This one is in Laway, Bohol. This is the Lubbock Church. Some additional pictures. Not only churches were damaged by this earthquake, including reinforced concrete buildings like the Bohol Capitol, as shown in these pictures. So the question is, why do we need to preserve our heritage structures? Let me quote the quotation by Sui Yao. Says, "The old house is like a book. Enter and read it, and you will find yesterday, today, and tomorrow written on the page." So basically, cultural heritage preservation is all about maintaining our nation's shared links with the past, the people's shared connections. Cultural heritage is also a set of symbols or links to the past. So imagine the impact of the earthquake in Bohol, wherein many churches were destroyed, some of them totally collapsed. Hence, the past about that particular structure is lost. Let me present some principles and definitions on heritage conservation using the book by architect Augusto Villalon on Lugar, Essays on Philippine Heritage and Architecture. Architect Villalon is one of the advocates on heritage conservation, not only in the Philippines but all over the world. First definition is conservation. It is actually a multidisciplinary uh, means of safeguarding an old building. It involves conservation architects, engineers, urban planners, architectural and art historians, technicians, anthropologists, and many more. And they contribute their technical knowledge to the conservation of a heritage structure. There are various methods of building conservation, and let me define each of these methods. Preservation is the cleaning and maintaining of a structure in order to extend its lifespan. This is the optimum and the best thing to do in heritage conservation. Shown on this slide are structures, heritage structures. This one is the Intramuros Church, the San Agustin Church, which was not destroyed during World War II. And of course, Iloilo's Pride, the Miaglao Church, which is a UNESCO World Heritage Structure. Restoration is the process in which interventions and additions that have been made to a structure at a later date are removed to return the structure to its original form. So the original look is returned and added. Contemporary embellishments are also removed. Shown in this slide are some heritage structures in historic city of Vigan, Ilocos Sur. Some of these structures were preserved, some of them were restored. Reconstruction is the rebuilding of a faithful copy of a structure based on original period plans and done under strict supervision by a conservation team. The classic example of reconstruction is, of course, the heritage structures in Intramuros, since most of the structures except the San Agustin Church were destroyed during the war. And these structures now at Intramuros are basically reconstructed heritage structures. Another example is, of course, the Las Casas Filipinas de Azucar. It is an open museum in Bataan. Some of the structures are original, some of the structures are reconstructed. Adaptive reuse is the adaptation of an old structure to allow the introduction of a modern function into the old structure. Old buildings are not demolished, but recycled into modern uses. The classic example in the Philippines is the rehabilitated structure, which used to be the Tutuban station at Manila-Dagupan line of PNR and is now called the Tutuban Center Mall. So the envelope of this structure was used and became a mall. The final strategy is remodeling, and it involves the drastic renovation without regard to the structure's original state and changes its character completely. When an old structure is remodeled, its authenticity, ambience, and historical value are gone forever. So this is not the best thing to do for heritage conservation. An example is in Tayabas Church. No? Okay, in this particular remodeling, there were concerns on the renovations, specifically the ceiling part of the church. The comments are almost the entire wood ceiling removed. The ceiling cannot anymore be claimed to be an authentic piece if you compare the before and the after remodeling. So the original church may exist, but some of the portions are not anymore authentic. Okay, according to the NCCA, the objective of conservation is to preserve for posterity the unaltered or the authentic state of a heritage structure, historic monument or site, as close to its original condition as possible, and that special care should always be given to carrying out restoration works as heritage structures are irreplaceable. So it is advised that it is better to preserve than to restore, and to restore than to reconstruct. The key to heritage conservation is the less you touch, the better. So the best scenario in heritage conservation is ongoing maintenance to the original structure. Since authenticity is of premium importance in heritage conservation, restoration must never be an imitation, falsification, or an attempt to compete with the original. So restoration should not alter as much as possible the original. Okay, so when restoring monuments, it is advised that you must use materials similar to that of the original. So based on the concept of authenticity, the various methods of building conservation are rated, no, as shown, where preservation is, of course, the best strategy for heritage conservation, followed by restoration and adaptive reuse. Then reconstruction. Remodeling takes the last suggested strategy for heritage conservation. Let me focus now on adaptive reuse of heritage structures. So, according to the reference by Villalon, cultural heritage preservation respects the past, okay, of course, but does not bind us to it. Okay? It does not prevent us from moving forward. Instead, it strengthens and enriches our lives by preserving the valued traditions of our ancestors. Okay, so there is a present misconception that heritage structures should be lifestyle museums like Vigan and Taal. Okay, so we venerate them as monuments to the past rather than reusing them and refitting them into our daily lives. Hence, adaptive reuse is proposed, no, as another strategy for heritage conservation. So what we need is to develop or to assign heritage zones in cities where heritage structures are rehabilitated and reused not only as museums but for modern living. So heritage structures should blend with newer and modern buildings. Some adaptive reuse principles. Okay, adaptive reuse is the adaptation of an old structure to allow the introduction of a modern function. Okay, all buildings are not destroyed but recycled into modern uses. Reuse is the integration of old structures into the present. And in adaptive reuse, we use the envelopes, no, that are not destroyed but rehabilitated to serve our daily lives. The building envelope should not only be used as venues for museums, cultural functions, or cafes, but must also be used for contemporary everyday use like banks or offices or malls. Reuse looks at heritage structures as a group like in heritage zones. Therefore, entire neighborhoods of old structures are saved from decay and live once more. Examples of best practices of adaptive reuse can be found in other countries like Sydney, Australia, wherein prisons were converted into malls, hence adapting old buildings for modern use. Kuala Lumpur, Malaysia. Heritage buildings for commercial use are, are maintained and stand side by side with modern buildings. So there is a blending of the old and the new. Singapore. Heritage buildings for commercial use. Examples, we have here the building. Potato Head is housed across 4 floors of a heritage Keong Saik Road, which serves impressive foods and drinks. The Majestic Theatre, similar to our Metropolitan Theatre in Manila, is Singapore's famous Cantonese opera house and has been transformed into a shopping mall. Of course, Tutuban Center Mall, which was rehabilitated to become a center or commercial center. In Iloilo City, an ordinance declaring certain building structures or sites as local heritage or legacy buildings and creating the Iloilo City Cultural Heritage Conservation Council. So a heritage zone was created along Cali Real, identifying specific buildings as shown in the list. And these buildings include neoclassical style and Art Deco type of architectural buildings. And most of these buildings are used for commercial or assembly areas. There is a Republic Act number 10066, an act providing for the protection and conservation of the national cultural heritage, strengthening the National Commission for Culture and the Arts and its affiliated cultural agencies and for other purposes. Okay, in this RA, there are relevant definitions, no? Like what is built heritage. Okay, and it refers to architectural and engineering structures as but not limited to bridges, government buildings, houses of ancestry, traditional dwellings, quartels, train stations, lighthouses, etc. A heritage zone shall refer to historical, anthropological, archaeological, artistic, geographical areas and settings that are culturally significant to the country. And adaptive reuse refers to the utilization of buildings, other built structures and sites of value for purposes other than that for which they were intended originally in order to conserve the site, their integrity, and authenticity of design. Also in this RA, there are specific sections which I would like to highlight. For example, Section 5, structures dating at least 50 years old are included in the list of important cultural property that will be protected against exportation, modification, or demolition. Section 7, privileges for cultural property includes priority in government funding for protection, conservation, and restoration. Incentive for private support of conservation and restoration, and priority protection during natural disasters and other emergencies. Section 12 is the designation of heritage zones, and Section 13 is the maintenance of heritage zones. A heritage zone shall be maintained by the LGU, and the LGU will implement adaptive reuse of cultural property. So what is the role of structural engineering in heritage preservation? First, let me list down common reasons for assessment of heritage or historic structures. Number one, there may be visible structural deterioration or known failure. Examples are corrosion of iron steel members, cracks or dislocated masonry, or the tilting of the walls. Two, there may be structural failure due to the design and construction. Three, deterioration of the building enclosure or the envelope, the facade and the roof system, okay, due to various environmental factors like water infiltration, corrosion, rotting of wood, etc. Four, there is a lack of documentation regarding the structural capacity of the building. And many historic buildings do not have a design live load capacities, and an analysis may be necessary to determine the existing capacity due to the present live load, especially when it is used for adaptive reuse. Okay, change of use or increased capacity is required. As mentioned, adaptive reuse often changes the live load requirements of the building. Number 6, there may be severe events which may have damaged the existing structures due to earthquakes, wind, flood, or blast. And of course, number 7, because of the campaign for heritage conservation, compliance to heritage preservation requirements. Structural engineering is a key to cultural heritage preservation and disaster risk reduction. So we have here cultural heritage preservation, disaster risk reduction, and structural engineering intervenes and connects these two concepts. Heritage structures must be assessed and retrofitted versus hazards that may lead to damages to heritage structures, hence reducing disaster risk. So structural evaluation actually involves from a simple, rapid, not costly level 1 procedure to a more complicated, time-consuming and expensive level 3 assessment and evaluation. Level 1 involves rapid visual screening or checklist assessment. Level 2 involves a more detailed inspection, non-destructive test, semi-destructive testing, and computer modeling and analysis. And level 3 involves a more sophisticated non-linear and structural retrofitting. So in level 1, rapid screening and prioritization, it involves the following objectives: to group the buildings according to asset value, importance, or use, to rank the buildings according to risk, to prioritize which buildings need immediate attention for a more detailed structural evaluation, and to decide what action must be done on the buildings, either retrofitting, strengthening, repair, or simple maintenance. So this is an example of a set group of buildings, and they were screened based on risk. Buildings with higher risk must be prioritized for more detailed inspection. Level 2 involves non-destructive and semi-destructive tests. Okay? Non-destructive testing is the most appropriate approach for estimating in-situ mechanical properties of the materials and diagnosing the structural condition of heritage structures, since there will be minimal alteration of the structure, thus preserving the authenticity of the heritage structures. So the challenge in NDT is for developing Test for unreinforced masonry, wood, reinforced concrete heritage structures with minimal alteration. And these are examples of NDT and SDT, rebound hammer, rebar locator, and concrete core test. Aside from those tests, there are a list of various non-destructive and semi-destructive tests as shown in this table. And each of these tests has its own objectives, and when to implement this test depends on the intervention. Okay, so before the intervention or retrofitting, you have to conduct preliminary investigation and survey. You must appraise the geometry and the foundation of the structure, assess the material properties, and then you apply model validation. During the intervention, of course, you must make sure that you maintain quality assurance, considering authenticity. After the intervention, let's say retrofitting, you evaluate the effects of the intervention on the structure for safety and authenticity. And of course, you monitor the performance of the structure due to future events. Shown in this image are non-destructive and semi-destructive tests conducted on one heritage structure in Quezon. This is a research conducted by one of the graduate students at De La Salle University on a heritage structure in Quezon. So these are the non-destructive and semi-destructive tests, concrete core tests, rebound hammer tests, rebar locator, and ultrasonic pulse velocity or UPV. Also in this in the same test, so this is the original heritage structure in Quezon, and this is the computer model, okay, of the structure. It was analyzed and its performance was assessed before and after intervention. Finally, level 3 involves structural retrofitting, and there are various ways of retrofitting from local to global. And depending on the type of material, there are various strategies recommended for structural retrofitting. The challenges in structural retrofitting of heritage structures are as described here. First, historic materials should be preserved and retained to the greatest extent possible and not replaced wholesale in the process of retrofitting and strengthening. New retrofit systems, whether hidden or exposed, should respect the character and integrity of the historic building and be visually compatible with it in design. If retrofitting work is done, it should be reversible to the greatest extent possible to allow removal for future use of improved systems and the traditional repair of remaining historical materials. Thank you very much for your attention. So, acknowledgement, this is sponsored by UCL, UP Visayas, CPU, and De La Salle University.